Good morning, class. At this point, we're looking at differential calculus. We on page 153 or 43? No, 53. No? You had exercise 5 to do for homework. Not so? Right. So here we are told determine the average gradient between -3 and that there. What was that answer there? We do this, then f of -3 plus h is simply -3 plus h squared minus 5 into -3 plus h, which is going to give us 9 minus 6h plus h squared, I'm multiplying that out, plus 15 minus 5h minus f of -3. f of -3 simply going to be -3 squared minus 5 times -3, which is 9 plus 15, which is 24 over h. Not so? Now 15 plus 9 is 24, minus cancels. This is going to give us -11h. Take out h as a common factor. So it's -11 plus h over h, which is -11 plus h. What's that? You just pull the numbering down here. This is exercise 5 on page 153. Exercise 5 on page 153. Alright, so then it says determine the limit as h approaches 0. So that was A in B. The limit as h approaches 0 of no, I was actually doing B, not so. This is B, B's answer. So in other words, the limit as h approaches 0. So if I see h up at 0, so this answer is -11. Not so? 1.2's answer is -11. Just coming back to A. A's question was determine the average gradient between those 2 points. So when you do the substitution, f of -3 plus h worked out to be what? H squared? Sorry? Minus 11? H? Plus 24. And f of -3? 24. Not so. So for your average gradient, it's going to be f of b minus f of a over b minus a. Okay, to most of us, we just use the basic quadratic gradient formula. Okay? So remembering this point here is -3 and 24, and this point is -3 plus h and h squared minus 11h plus 24. So when we work out the average gradient, it's going to be h squared minus 11h plus 24 minus 24 all over -3 plus h minus 3. But that cancels, leaves you with h squared minus 11h all over h. And take out h as a common factor, is h minus 11. I actually worked out this. Sorry about it. Compare your answer into 1.2 and 1.3 and explain the result. No, I'm missing something. Use first principles to determine f prime x. So when we used first principles, Just take this out. So if you look at the formula for first principles, it's going to be f prime x f prime x equals the limit as h approaches 0 of f of x plus h minus f of x all over h. That's the formula. So if f of x was equal to x squared minus 5x, then f of x plus h is simply x plus h squared minus 5 into x plus h. It's probably behind the thing there on the side. Let's pull this up here. So that would simply give us the limit. Don't forget to rewrite the limit until you apply the limit once you do the substitution. Otherwise you're going to drop the limit, you're going to lose them all. Okay? So f of x plus h, of course, is going to be x squared simply going to give you x squared plus 2xh plus h squared minus 5x minus 5h minus in brackets x squared minus 5x. Multiply the bracket out, so it's x squared plus 5x, and this is all over h. So we got the limit as h approaches 0. This will cancel, it will always cancel in this format here. H is a common factor. I'm left with 2x plus h minus 5 all over h. It gives us 0. Wherever we see a h, we put a 0. The answer is simply 2x minus. Okay. Okay, copy your answers 1.2, which is negative 11, and 1.3. We didn't finish this yet, no? So they wanted to know what is f prime of negative 3. So f prime or f dash of x with a derivative of f is 2x minus 5. So f dash of negative 3 is going to be 2 times negative 3 minus 5. So that's going to give you negative 6 minus 5, which is negative 11. Okay. So the question says, what's the difference between the two? But we know what this is, no? We say f prime of x, what is that? The general gradient anywhere along the curve. Not so. Whereas when we substitute this negative 3 in, that means to say it is the gradient of the tangent to the curve at x is equal to minus 3. Okay? In this case, it's going to be negative 11. On the other hand, when we work out our average gradient, the average gradient is basically what happens between the 2 points given, which is negative 3 and negative 3 plus h. But since negative 3 plus h, that is tending to 0. So that means to say the distance between the 2 points is negligible. It's almost nothing. Okay? So that is basically the same answer. Why? Because the 2 points that we normally work out the average gradient became 1 point. Or the distance between the two is negligible. Okay? Or you can just neglect that or leave it out. Determine the equation of the tangent at x equal to negative 3. So the equation of the tangent as we know at this point, the equation of the tangent will be in the form of y equals mx plus. Not so. But we have the gradient at minus 3. Remember that your derivative is simply a gradient. Okay? So what is the gradient at minus 3? Negative 11. So y is equal to negative 11x plus c. Now to calculate c, I need a point that's lying on this curve, on the straight line. Not so. Or on the curve, which is the point of contact. Alright. So how do we get the point of contact? By substituting negative 3 into f of x, into the original function. So it's negative 3 squared minus 5 times negative 3. That gives us 9 plus 15, which is 24. So the point of contact is negative 3 and 24. This you could have gotten actually from your previous calculations. No? So you can substitute negative 3 and 24 into the straight line, remembering that's the x and the y. So 24 is equal to negative 11 minus 3 plus c. This is positive 33. Bring it over, is negative 9. Is that correct? So y is equal to negative 11x minus 9. You must be able to do this. It's worth 4 marks. Alright, and it's often asked. Alright, consider the function. This one I need to do with you as well. So this is the other way they could ask. Okay, if this one comes in, it's worth 7 marks. It comes in like this. No, not 7, 6 marks. I'm seeing a 7. So let's do this. So the question says use the definition to find the derivative of g of x. As I said before, if they ask you definition or by first principles, you do this process we're going to do now. Okay. And this is normally the first question. It's either this or the limits is your first question in calculus. Okay. So we're given g of x, so g prime x is equal to the limit as h approaches 0 of g of x plus h minus g of x all over h. Okay. So if g of x is equal to negative 7 over x, then what is g of x plus h then equal to? Negative 7 over x plus h. Not so? So I do my substitution. I go the limit as h approaches 0. Okay? Of g of x plus h, it's going to be negative 7 over x plus h minus negative 7 over x all over h. Okay. Get rid of the bracket there. So we have the limit as h approaches 0 of negative 7 over x plus h plus 7 over x divided by h, and h over 1. What's your LCM inside the bracket? So we go the limit as h approaches 0, x into x plus h. So the sum is multiplied by x. So it's negative 7 times x plus 7 into, this must multiply by x plus h. Must be multiplied by 1 over h. So we have the limit as h approaches 0. Let's get rid of the bracket. Let's pull this down a bit. Yeah? Sorry? This must h over 1 must become 1 over h. No, it's first h over 1. Remember, this is divided by h. Can you see that? And this h here is h over 1. Okay? So we multiply, get rid of the bracket, so it's negative 7x plus 7x, 8x plus 7h, all over xh into x plus h. Multiply that there. This cancels. So we left with 7h over xh into x plus h. Then that h is cancelled. Which now leaves us with the limit as h approaches 0 of 7 over x into x plus h. So if I see a h, I put a 0. So the answer is 7 over x squared. Okay. That's nice. Okay. Yes? xh. This here is, you see, set x multiplied by h. Okay, so I'm going to write it as one fraction. Alright, you all okay with that? So let's look at the next question. So this here, I'm going to write it there. That g dash of x was 7 over x squared. Let's look at 2.2. Determine g dash of negative 7. So g dash of x is 7 over x squared, so it's 7 over negative 7 squared, which is 1 over 7. Not so? What does this represent? The question says in 2.3. What is represented by g dash of negative 7? The gradient of the tangent to the curve at x is equal to negative 7. Okay? 2.4. Determine the equation of the tangent. So y is equal to mx plus c. So y is equal to 1 over 7x plus c. How do you calculate c? You must substitute a point that this line is going through, which is g and my negative 7, which gives us negative 7 over negative 7, which is 1. So the point of contact is negative 7 and 1. So you're going to substitute negative 7 and 1. That's x and a y. So we have 1 equals 1 over 7 multiplied by negative 7 plus c. This is negative 1, not so? Becomes positive 1. So c is 2. So y is equal to 1 over 7x plus 2. Okay. Any confusion there, people? No. Okay. I'm going to do is I'm going to take this off here. People notice I'm spending a lot of time on this here. Okay? Please don't miss out this question in the exam. It says use first principle to find the derivative of f of x at the point where x equal to minus 1. Again, the first thing we do is we use the formula. F prime x equals the limit, you always write down the formula first. H approaches 0 of f of x plus h minus f of x all over h. If f of x is equal to negative 5x cubed, then f of x plus h is going to give you negative 5 into x plus h cubed. Okay? At this point, you should know already how to multiply the story out. So it's going to give you x cubed plus 3x squared h plus 3xh cubed squared plus h cubed. And I multiply the negative 5 in. So you get the limit as h approaches 0 of negative 5x cubed minus 15x squared h minus 15xh squared minus 3h cubed minus negative 5x cubed. Not so? And that's all over h. This becomes positive 5x cubed, not so? And that now cancels that in your next step. What do we do now? We take out h as a common factor. I'm left with negative 15x squared minus 15, yes? Where? Where? On the last? Cubed. It's supposed to be a 5. Thank you. It's supposed to be a 5. Absolutely correct. So that's going to go. H's cancel. Wherever I see h, I put a 0. So the answer is negative 15x squared. But what's the question? We must work out at negative 1. So therefore, f prime of negative 1 is equal to negative 15 negative 1 squared, which is negative 15. Again, what does that represent? It is the gradient of the tangent to the curve at x is equal to negative 1. Alright. We look at the next question in number 4. You'll see use first principle to find the derivative of g of x at the point of x equal to 4. So what you must note here again, same story. First derivative. So g prime of x equals the limit as h approaches 0 of g of x plus h minus g of x all over h. If g of x is equal to 2x minus 5, then g of x plus h is going to give you 2 into x plus h minus 5. There you go, the limit as h approaches 0 of 2x plus 2h minus 5 minus g of x, which is 2x minus 5 all over h. Get rid of the bracket, so it's the limit as h approaches 0 of 2x plus 2h minus 5 minus 2x plus 5 all over h. So that cancels, this cancels. So we left with the limit as h approaches 0 of 2h over h. So the h is cancelled. So as you can see, the limit as h approaches 0 of 2. There's no way that I can substitute 2 in here. 0 into the h. There's no h. So what's my gradient? Therefore it is just 2. Not so? But what type of graph is g of x? What type of graph is g of x? Straight line. What is the gradient of this line? 2. Not so? Why? Because that is the gradient of the line anyway. Not so? But why did I have to go through this? Because that says use first principles. Make sense, people? So therefore, g prime of x was 2. So g prime of 4 is also going to be 2. Anywhere on that line, the gradient will be 2 anyway. Okay. Let's carry on with our lives. Using definition, as we said, definition is the same as saying by rules. So again, let's look at number 5. You got f of x, so f prime x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. So what is f of x? Minus 3. What is f of x plus h? Minus 3. Can you see that, people? Both is minus 3. There's no x in that equation. So we go the limit as h approaches 0 of f of x plus h, which is minus 3, minus f of x, which is minus 3 all over h. So that's the limit as h approaches 0 of minus 3 plus 3 over h, which is the limit as h approaches 0 of 0 over h, which is the limit as h approaches 0 of 0. You see, there's no place to substitute h in either. So that is simply 0. So if f of x, f prime x was 0, then what is f prime of negative 5? 0. F prime of 100? 0. Can you see that, people? What graph is this? Y is equal to negative 3. What type of graph is that? The straight line is, but it's parallel to the. So you got the y and an x here. Y is equal to minus 3 is a line going through like this. Not so at the point of minus 3 on your y-axis. If the line is parallel to your x-axis, it has a gradient of 0 anyway. Not so. So since it has a gradient of 0, anywhere along this line, this gradient will be 0 anyway. Does it make sense? Right. So make a note there, the derivative of a constant will always be 0. Very important, the derivative of a constant will always be 0. As you can see there, the derivative of a constant was 0. You'll still get a lot of those there. But as we're going along, we're now building our understanding of derivatives. Use first principles to find the derivative. First principles again. F prime x. F prime x equals the limit as h approaches 0 of f of x plus h minus f of x whole over h. If this is actually g, no? So g of x is equal to negative 3x squared. Then g prime g of x plus h will simply be negative 3 into x plus h squared. Okay, so I can multiply that out one time. So it goes the limit as h approaches 0 of f of g of x plus h will simply be negative 3x squared minus 6xh minus 3h squared minus 3x squared all over h. So that goes the limit as h approaches 0. This would simply give us positive, not so. So negative 3x squared plus 3x squared cancel. We take out h as a common factor, so it's negative 6x minus 3h all over h. So h is cancelled. Wherever I see h, I put a 0. So the answer is negative 6x. Okay. Question 7. Use first principles. The answer should have been negative 12x squared. Okay. The next one, your first principles there is going to be negative 18x. Okay. Number 9. Use first principles. This is the derivative of a constant. The answer will work out to be 0 there. I'm going to do number 10. It's often given in that format, okay? As I said before, they can give it in the where your x is in your denominator as well. Huh? So let's go again. We are told that use first principles to differentiate f of x. No, not that one. Number 10. Use first principles to determine g prime of x. So g prime x will be the limit as h approaches 0 of g of x plus h minus g of x all over h. So if g of x is negative 6x squared minus 4, then g of x plus h will simply be negative 6 into x plus h squared minus 4. And go straight into the simplifying there. So it's a limit as h approaches 0. There must be an equal sign there. Of g of x plus h will simply be negative 6x squared minus 2xh times 6 is negative 12xh plus no, minus 6h squared minus 4 minus negative 6x squared minus 4 all over h. That will give us the limit as h approaches 0 of negative 6x squared minus 12xh minus 6h squared minus 4 plus 6x squared plus 4 all over h. That goes the limit as h approaches 0. So 6x squared minus 6x squared cancel, minus 4 and 4 cancel. H is a common factor, I'm left with negative 2x minus 6h all over h. And from here you can see that negative 6x and negative 6 is also common along with h. But I don't take it out because otherwise I must multiply it in again. So that cancels, and wherever I see h I put a 0. The answer is negative 12x. Okay. So let's go here again. The next one. We did of that, we did of each of these. Okay. But now, okay, so this answer here would have been, the answer to number 11 is negative 9 over x squared. The next one is negative 6x squared. No? The next one is negative 5 minus 6x. Substitute that in. You get negative 5 minus 6x. When you substitute that in, f dash of 2 gives you negative 5 minus 6 times 2 is 12. It's negative 17. Yeah? And then the last one here, use first principles. That gives us negative 4x plus 1. Sorry? Okay, and I went all the way now. Okay. So the next question says, where does this fit in? Term the equation. I think we did this already, no? Huh? Yes, we looked at that there. So we'll take a new page. Okay, so that's first principles for you. Okay. So what we need to look at now is the rules of differentiation. Okay. Here's the specific rules to differentiate. Okay. Now just take you one step back. What was the first sum that we differentiated? Let's go there first. When we use the limit and all of those things. Let's get the first sum. Yeah, from first principles. If we look at this sum here, okay, we are given f of x equals 2x squared minus 3x minus 5. And when we worked out our derivative, we got that. What did you notice? What do you notice? Do you find the relationship that is existing between that and that thing? Yes. If we look at this number here, there's 2. Not so? 2 times that 2 is 4. And if I minus 1 by that, I get 1. Can you see that? You see there's a 1 here on that x. Not so? What is 1 times negative 3? Negative 3. If I subtract 1 from it, what do we get? 0. Anything to the power 0 is 1. So that is 4x minus 3. No? There's normally an x here. If I put the x here, then what's the exponent on that x? 0. Can you see that? What's 0 times negative 5? Negative 5x. Sorry. Negative 5 times 0? 0. Or positive 0, whatever. No? X. Minus 1? Minus 1. So anything times 0 is 0. That falls away. And the note that we made earlier on was the derivative of a constant will always be 0. Can you see here? Negative 5 was a constant. And it just falls away. Does it make sense? Let's carry on here. When we worked out this derivative here, what was the answer? Exercise 4, go back to number 1. The derivative here was 2x minus 1. Can you see that? So if I take the rule into account, I say f dash x, f prime x equal to, there's a 1 there. Not so. What's 1 times 2? 2x. If I subtract 1 from it, what do I get? 1. There's a 1 and a 1. 1 times negative 1 is negative 1, minus 1 is x to the 0. X to the 0 is 1, so that falls away. The derivative of a constant, 0. So there's my answer. But look at number 2. If f of x equals negative 1 over x, I first bring that up, becomes f of x is equal to negative x to the minus 1. Not so. If I multiply the exponent by the coefficient, what's negative 1 times negative 1? 1x. You take 1 away, you get minus 2, which is 1 over x squared. Can you see that, people? And that was the answer we got there. If you look at g of x equals 5x cubed, you say 3 times 5, what's 3 times 5? 15. Minus 1 squared, so it's 15x squared. You guys understand? Huh? No. What we're doing is, we're multiplying the exponent by the coefficient. We subtract 1 on the exponent. We look here, if g of x was 5x cubed, you take that exponent, which is 3. 3 times 5, 15. So it's g prime of x is equal to 15x minus 1 squared. Okay, yes, Michael?
It's the power.
Sorry?
It's the power.
No, it's not the power rule. The power rule is something else. We get the multiplication rule, you get the quotient rule, the multiplication rule, no? Product rule, quotient rule, and power rule. Power rule is something else. This is just the basic rule of differentiation. Okay? But product rule and quotient rule, that's something else. That you do first year university. But going back to this year, here's a specific rules for differentiation. Which page are we on here, people? Unit 4? 154, okay. Okay, so let's read what they are telling us here. The formula for differentiation of a function f of x equal to a to the exponent a n to the ax to the exponent n is given by f prime x equals. So what did we say earlier on? We take the exponent, we multiply by the coefficient. So a times n is na, so f prime x equals x and a minus 1, so it's n minus 1. Okay, again, we're just taking the exponent, we're multiplying it by the coefficient, you minus 1 from the exponent on the x. That's it. But when we do that, it must be in the form of ax to the exponent n. It must be in that form. If it's not in that form, we must get it in that form. Right, you guys understand? And also you should have noted at this point, every time I apply my derivative, I show f prime x. Can you see that? I don't just say f of x will equals. I just differentiate it or show the change in by saying f prime x. Okay. So let's read again what they're saying here. The formula for differentiation of a function is f of x equal to ax to the exponent n is given by f prime x is equal to a n x to the exponent n minus 1, for n is an element of real numbers. All the real numbers can be considered here for n. Then we are told there are many rules for differentiation, but you are required to use only one. Okay? You can use f prime x equals a n x to the n minus 1 to differentiate the function if you can express each term in the function in the form of a n to the exponent x. Which means to say, if you can get it in this form of a n to the exponent x, then you can differentiate. Okay? As I've indicated earlier, that there are more rules to differentiation. A lot more. Okay, but just for now we're keeping it simple. To differentiate the function. If you can express each term, alright, we said that. If it is therefore often necessary to write in terms of the correct format before. Wat gaan nou hier? Okay. It's therefore necessary to write it in terms of the correct format before you can apply the formula. You can denote the derivatives in different ways to make sure you know how to recognize and work with each. So remember we worked with f of x and g of x. Not so. So for f of x, if it's given as f of x and we apply the derivative, we say that is f dash of x. When it was g of x and we applied the derivative, then it became g dash of x. Not so. Now if you have y equals 5x cubed for argument's sake, and we apply the derivative, that now becomes the derivative of y with respect to x. So that's dy over dx. Can you see that? So what if here's the s and we got is equal to 5t cubed? What would that have been when we apply the derivative? That would be ds over dt. That's meaning to say the derivative of s with respect to t. It makes sense? Okay. And then another way that they do it, they also say your derivative of x, if you have negative 5x cubed, that would simply be. Now if you look here, here's the derivative with respect to x. So how am I going to show the change? It's just simply 15x squared. I just drop the derivative. Can you see that, people? Another way that they do it is the derivative of x of negative 5x cubed. That simply becomes, you drop the d, is negative 15x squared. And there we go. Okay. So again, when we apply the derivative, there must be a change in something you are doing. Okay, as in the subject of the formula. Changes from f to f prime. If it's d over dx, we drop the d. Okay, we drop the derivative sign there. Okay, so let's look at a couple examples here. So these are the examples on page 154. So we are given f of x equals 2x minus 3 and 4x plus 1. So the question you should be asking yourself, is this expression in the form of ax to the exponent n? No, because as we multiply it. Not so. So what's the first thing we need to do? Get rid of the brackets, multiply it. Okay, so do that quickly. So what do we get? F of x equals 8x squared plus minus, there's plus 2x minus 12x is going to give you negative 10x minus 3. Now you apply your derivative. Apply your derivative quickly. Alright, so we apply derivative, what do we get? 2 times 8 is 16. Minus 1 is 1. Not so. There's a 1. 1 times negative 10? Negative 10. That x fall away. Derivative of a constant? 0. You all got that? Right, looking at the next one. Y is equal to 3 over x. Is that in the format of a x to the exponent n? Is that in that format? No. Which means to say I must get it in that format. How? Bring that 3 up. So bring the 3 up and you apply the derivative. So that gives us y equals 3 x to the negative 1. You all agree with that? Can I apply the derivative now? Yes. So this will simply be
Your attention please. One way will meet in the hall now during break. One way will meet in the hall now during break. Emma Rose, can you please report to the office? The second-hand clothing shop is open now during break. Scarves and skirts are in stock now. Thank you.
So I can apply my derivative. So what's negative 1 times 3? Negative 3. Minus 1 from that, I get x to the negative 2. Do you guys understand? For homework, I would like you guys to try the next 3. Okay? But also prepare for tomorrow's test, okay?
Your attention please. One way will meet in room 43. One way will meet in room 43 now during break. Thank you.
It's going to be the first part of calculus. So limits and first principles. Now that for tomorrow's test. People enjoy this every day. Good morning class. Afternoon.